There we go. All right. Hello, everyone. I think this is working. It was maybe a bit of a gamble doing my first ever YouTube stream for something this big, but here we are. We'll see if this all falls apart or not. Hello, I am Dr. Shane Saunderson, and yes, that feels really good to say. I'm sure the effect will wear off after a few weeks, but for now, I'm going to lean into it. And as I've seen in the chat, I think many of you are curious what in the world I've been doing with my life for a few years other than growing a very gray beard. Well, I've been researching robotics and a very specific type of robotics, as all grad students do. They get very deep and very particular in what they do. And today I want to share a bit about my research into persuasive robotics, which is both as creepy as it sounds, but also probably as valuable as it will sound. And we're going to get to it in a little bit. But before we go down that road, the first question I want to answer, because I get asked this a lot, and I know I asked it before I did a degree, but it's hard because there's really no good answer, is should I do a PhD? I know a lot of people are thinking this could be something maybe one day I want to do. Now, when I asked this years ago, no one would give me a straight answer because it really does ultimately come down to your own decisions and, what you're willing to do, go through, stomach, and those kinds of things. All I'm going to do is present a couple of pieces of data for you to make your own decision with. So this was me in 2017, trying on a tie, checking it out just before going to my orientation at Massey College back early. And this was me in the depths of writing my dissertation just this last fall. So, should you do a PhD? That is entirely up to you. Just realize what the potential effects could be. Now, we're not here to talk about my growing gray facial hair. We are here to talk about robots. But what specifically do we want to talk about when we get into robots? Well, particularly what my research focuses on and what I want to get into today is we talk a bit about the influence that robots can have over people. And I do this not simply to scare you, but to very intentionally make you reevaluate your relationship with technology. You see, this is important for you to understand what technology does to you so that you can make informed decisions, because if you don't, then very bad things could happen. So I just want you to be very aware of what's going on with technology. There's a lot of good that we can do with technology, and I'm still a big positive person when it comes to technology, but there's a lot of dangers that happen alongside technology too that we need to be aware of. So at the end of the day, let's all make sure that whatever we do with technology, we have fun. Now, who the heck am I? Probably most of you on here are either friends or my family, so don't really need to go through this, but I guess who have I been for the last few years? Well, I've been doing a PhD in human-robot interaction at the University of Toronto. I've been supervised by Professor Goldie Najat, who's an expert in robotics and social HRI. But I've also had the great fortune of working with Professor Li Shu, who runs the Psych-Eng specialization, sort of a collaboration between psychology and engineering. And I was exceptionally fortunate to have Jason Plax, also from the School of Psychology, working with me as well. Before this, those of you who don't know me that well, I actually had a business background and an engineering background, so I've got this sort of strange confluence of engineering, psychology, business. But at the end of the day, I really do dig robots. I think they're cool, and I think we can learn a lot about them. But now, why is that? Why should anyone study robotics? Well, I'm going to use a bit of an analog here when we talk about a robotic arm. So if you look at a human arm, for example, and you're someone who's studied maybe kinesiology, you might understand things like how an arm moves and, where joints are and how different things pivot and move around. And then maybe, a step up if you did like a medical degree, you might actually get to dissect human arms or at least see different vivisections and different diagrams of them so you can understand more about the musculoskeletal system and actually understand how it works. So not just what it is, but how it functions, how these muscles move and these joints rotate. And I would say if you go even one step further, if you want to get it into engineering, you could build your own arm, which is a kind of cool thing because what it lets you do is not just understand the how, but it really gets into the why behind the design of things. You start to understand, well, why is it that, our evolution has positioned our joint here and that certain muscles are needed to pull certain forces in this direction. And so in that same way that I think robotics has a lot of value to a very physical thing, my interest is really in robotics when we start talking about social things. We can run similar kinds of thought experiments. We can think about what happens to a robot arm if you added or subtracted a joint. And in the same way, you could think about a robotic mind and what happens when you add or subtract different personality features or intelligence features and what that does both to the mind and the intelligence itself, but also to us, people, because we're ultimately the ones that have to interact with these things. And really, it's that interaction that is probably paramount to anything else. And so this is the area that I study in. It's an area called social human robot interaction, which is sort of one of two subsets of HRI alongside physical human robot interaction. And this, of course, deals with the sort of everyday psychology of hanging out with robots and seeing how we feel. But it's, of course, beyond psychology and incorporates aspects of engineering, human factors, artificial intelligence, cognitive science, and even, as you'll see in this, philosophy and ethics, quite importantly, too. But maybe I'm getting a little bit ahead of myself because we haven't even answered one fundamental question, which is, what is a robot? In this day and age, the term gets thrown around a lot. I have certain friends, Charlie, who often love to call things like robotic process automation, and I get very frustrated because I say, well, no, that's not just real robotics. That's just, it's a AI piece or some machine learning or a chatbot or something like that. So a lot of people in the robotics community will identify a robot by having a physical presence. And one definition I love was from Mahamatrik, which is a robot is an autonomous system which exists in the physical world. It can sense its environment and act to achieve some goal. And there's a few pieces that are key to that. Number one, autonomous. And as we'll see, that's a big part of robotics and AI, is that they're supposed to be able to function at least partially on their own. Two, I already harped in my little soapbox and said they're physical things. Typically, that is a robot. Although, as we'll see, there's a lot of parallels between physical robots and digital chatbots or avatars or things like that. And then pretty critical to any control system is it can sense its environment. Implicit to that is it usually thinks about it and then it acts on that environment to achieve some goal. But now that goal is something that we're going to talk about a bit later because it's really critical, because the robot itself, very seldom is it going to have its own goal. That goal is almost the part that we give it. And that's really critical, as you'll see, to thinking about robots as social beings. Now, of course, a robot is not necessarily anything new. It's a term, at least, that dates back to the 1920s with a great Czech play called Rossum's Universal Robots, or Rossumvi Universality Roboty. I butchered that, so I'm sorry to all of my Czech fans out there. But, of course, even before, this play gave one of the first examples of robots uprising and killing everyone. Sadly, we didn't get off to a great start there. Automation, the thing that sort of was a precursor to robotics, is go back thousands of years. If we look back in the early ancient Chinese days, we saw people making mechanical men that moved around. You go up through, fascinations with gears and creating these sort of forms of artificial life. And one of my personal favorite in the background there was Jacques de Vacan's mechanical duck, which you could actually feed little pieces of bread and then it would poop on the other side. Truly fascinating, I'm sure, at the time. And so really, we've kind of always had this long fascination with creating artificial life. Now, I'm not going to speculate necessarily on whether this is just us wanting to play God or whether it's actually us wanting to learn more about ourselves and how we function. But for whatever reason, we've always been interested in robots. And I was no different. This was actually my very first robot. My parents bought it for me for Christmas, I think, for my 5th birthday or something like that. And I was obsessed with this thing. I, of course, drove it around, and in the most Canadian way ever, every time it bumped into something, it would say, oops, sorry, and back up. And I used to take this thing up to bed with me, so no cuddly teddy bear. I'd sit there with a hard plastic robot. But it sort of instilled this early fascination with robotics for me. And once again, even back then, this simple little Radio Shack robot had the basic premise of all robotics. It had sensors, a few little cameras and touch sensors. It had a controller, its brain, and then, of course, it had actuators. It had some motors that could move around. Now, of course, this is a very simple example of a robot, and in actuality, they really do come in all shapes and sizes. So here's just a smattering of robots that I've had the fortune to work with, except for Roomba, it's just cool, over the years, of basically all kinds of varieties, whether they're ruggedized things ready for out in the field and exploration, whether they're fully water sealed so that they can go explore coral reefs, whether they're something that we would sit in, like a wheelchair that can actually move around, or whether they're things that are a little bit more humanoid like us, that try to look, feel, and act like us. However, as I've alluded to before, this whole term of robot and this, I often use the word automation interchangeably because we're even starting to see parallels between physical robots and digital things or artificial intelligence. We're starting to blur the line between, what is a robot, what is a chatbot, what is just a piece of automation. And we're seeing, Google Home and Alexa. We're seeing self-driving cars, which are like robots on wheels. We're even seeing massive industrial automation or things like Ecobee or Nest in your homes, which are kind of like robots for your house. They can sense the temperature, think about what they need to do, and then actuate your furnace. These are all sort of weird examples of things we wouldn't immediately think of when we think about a robot, but in fact, they do blur the lines of a lot of this stuff. Now, I raise that only because I want you to think a bit more broadly, not just about some cute and cuddly humanoid robot, but to think a bit more broadly about automation when we talk about things today, because there's going to be a lot of parallels. Because what I had one big frustration with throughout my academic career was that I got to do some cool research, but those of you who know me know that my brain always wants to go in all directions. And so I found academia quite limiting because I couldn't go further, I couldn't speculate, I couldn't jump to the next thing. And so that's what I'm going to do today. We're going to have some fun with it. Now, if I've sort of laid the land of what this technology is, what are we actually talking about? Well, in the title, you saw that we use the word persuasion. And this is where things start to get a little uncomfortable and weird. But can technology be persuasive? Oh, buddy, can it? People have written textbooks on this stuff. Probably the most noteworthy is Brian Fogg's textbook, Persuasive Technology, which basically became the manual for how Silicon Valley manipulates us in this day and age. He went out there thinking, all right, this is what we're going to do, and now people use it on Facebook to nudge you to buy things or possibly worse. And so why I raise this is because it's important that we know this kind of stuff, because the technology, whether we like it or not, is influencing us. So we need to be informed about this. Now, you might look at me and say, well, no, not me. I'm very sure in myself, and I can't possibly be influenced by technology. But that's not always true. Very often, this influence happens in ways that we don't always see coming, and that we actually adapt to quite easily. I had an opportunity years and years ago when I was a consultant to work on a smart home project. A little bit different from this, but you'll get the basic point. And we interviewed a number of experts around the world, and one of them was Professor Diane Cook at Washington University. She was running a smart home experiment where students were actually living in these smart buildings, and they had one student that had some out-of-date software, and the student liked to study by lying down on their bed. I actually did that too. I was never one of those people that fell asleep, and so I would always study on my bed. But apparently, the system would note that the individual was prone in their bedroom and it was the evening, and so the system would just decide to turn the lights off. Now, I'm sure the first time this happened, someone would get up and flick the lights back on and say, well, that was weird. But, if it happened again and again, apparently this individual eventually just started taking the hint and going to sleep. So a simple little bug in some IoT code has suddenly changed this entire behavior of this individual from starting to go to bed early, probably waking up a little early, and maybe this is a change for the good, but maybe not. The challenge is we don't always know if it's going to be a good or bad thing. And very often we miss the dangerous parts. I know many people, love their smartphone, but I'm not a huge fan. I personally think these things are actually one of the greatest failures of modern technology. Yes, they've allowed us to communicate with people around the world and have the internet at our fingertips, but when we see things like people's growing depression from interacting digitally, feeling bombarded and overloaded by everything they have to deal with, these were implications that we didn't even see coming. There are highway text stops because something like distracted driving became such a problem that we had to actually start forming physical locations on the highway for people to pull over and check their phones. So it's sometimes very difficult when we are dealing with new emerging technologies to not think about all the different things that can go wrong, but it's critical. So how do we think about those things? Well, I promised you we were going to go a little bit all over the place today, so we're going to have actually a bit of a history lesson. Throughout my degree, I've also found a real fascination with looking backwards to see how technology has changed in the past. And one of the things I've noticed is that first, we fear disruptions to our purpose, to what we love to do. And for this, we go back about 200 years to the Weavers, or as you might know them, the Luddites. The Luddites has become a word that's become synonymous with just disliking technology, but that's actually a bit of a misnomer. Because what was actually happening during this time was these were all very skilled weavers that were suddenly having their jobs taken over by a new jacquard loom. So a very simple loom process that could be, you could hire somebody with minimum wage and have them come in and work the factories. Now, yes, there was definitely some job loss that happened here and maybe wages that got reduced, but more importantly, these weavers' guilds were built of individuals that had spent a lifetime perfecting this craft. This was their purpose. This was the reason they were put on this earth. And suddenly this new technology came in and made them obsolete without any considerations for how they would feel about that. So technologies can be problematic when they cut at our core purpose. We also struggle with social change. Shoshana Zuboff is a fantastic professor at Harvard University who did some great work back in the 70s that she published in her book, In the Age of the Smart Machine. Um, in it, she describes a chapter where she was actually doing ethnographic studies within a bunch of different offices that are undergoing computerization. So they're switching from traditional pen and paper into having computers put in place. Now, historically, the individuals that did this kind of work in banks or insurance companies would, do some basic hand calculations, maybe go over to their neighbor, pass off some paperwork, have a little chat, and then go back to their work. And as a team, these individuals would have a social network of getting things done for the company. Suddenly, the computer comes in, and this becomes their world and life. And if you're wondering how problematic this could have been, here's one of the quotes from Zuboff's interviews. No talking, no looking, no walking. I have a cork in my mouth, blinders for my eyes, chains on my arms. With the radiation, I've lost my hair. The only way you can make your production goals is to give up your freedom. That is some pretty harsh and visceral language for just giving somebody a computer. But this was what happened when we first were introducing computers into these otherwise very social environments. We've apparently now normalized all being radiated, losing our hair, and giving up our freedom. But at the time, this was the kind of huge shift that really disrupted a workplace to the point where many of these corporations that went through a computerization movement actually had to revert and try it again later on with some slightly better user experience. Another problem is that we will often mourn our loss of autonomy. When we lose parts of ourselves that sort of define how we are, that really rubs against us. And now, many of you will probably know what the Turing test is. It's sort of the thing proposed by Alan Turing to test whether a computer is smart enough that it could fool us into thinking it's a human. What maybe less of you will know is every year there's actually a prize called the Loebner Prize, where it's a big global competition that people compete their chatbots off to see how this works. Now, the Loebner Prize is always really fascinating, and in 2011, there was a fantastic book written by Brian Christian called The Most Human Human. And Christian actually ended up being one of the Confederates. So not one of the testers, not one of the competitors, but one of the people who was trying to convince you that they were a human while they're also potentially talking to another computer. And Christian had a lot of fun with this book, but in reading this book, there was one part that really stood out to me. Christian asked the question of every year, of course, the computers start tricking more and more people. But is it that our chatbots are truly getting better? Or is it that our own language is starting to become computerized? And the point that he was trying to make is that as we get more and more comfortable working with this technology, we give up parts of ourselves. We adopt more and more of the machine into us. And so in doing so, we change the very nature of who and how we work, who we are and how we work. So if you think about something like T9 texting, that was all frustrating when you had to push a key 3 times just to get there. But that's what ultimately led to things like LOL and BRB. It was short form because we were too frustrated. Later on, we all start using emojis. I can see 4 or 5 of them just in the chat right now. So instead of you saying, hey Shane, I'm really happy to hear you speak, I can just see a smiley face. These are changing the very nature of how we are social, and it's ultimately disrupting our own autonomy for who we are. So the point I'm making with all these things is that technology becomes problematic when it dehumanizes us. And this happens particularly when we hit things like a loss of autonomy, when we go at our purpose, or when it changes our social fabric. This is when technology becomes problematic. So this is the kind of thing that technology designers and developers like myself need to be conscious of and think about. However, I always like to go a little bit weird with some of my research and some of my work, so I said, all right, if technology is problematic because it can dehumanize us, what happens if we humanize technology? Now, you're all looking at this picture of a robot, and probably without even thinking about it, you thought, hey, look, the robot's waving at me. But really, it isn't. The robot has no intention. It's not saying hello. It just so happens to be that that robot's arm is positioned in such a way, and the fingers are maybe at a slight tilt that makes you think that it's moving and saying hello. So suddenly, you've looked at this robot, and otherwise just a piece of metal and circuits and wires and bolts has become something kind of human-like. What just happened there? Why did we all think this thing was waving at us? Well, in fact, there's actually some really interesting psychological phenomenon going on here. And this was one of my favorite pieces of research that I found. Actually, in my first year, this was ultimately what set off a lot of my own research. Some fantastic work going on in the 1990s at Stanford called the media equation. Now, The research that was done was very, very simple, but exceptionally profound. What they did is they had individuals come into a room and interact with a basic computer doing like a file renaming task, while the computer would pop up vaguely social messages. So things like "Go us" or "Aren't we a great team?" At the end of this interaction, they would then ask people to finish a short survey about their interaction, but they would do it in one of two conditions. People would either finish the survey on the same computer that they'd just been working on, or they'd finish the survey on an identical computer on the same desk, just, a few meters down the way. And what the researchers found was that when people finished the survey on the same computer, they were far less critical than if they finished it on the other computer. Think about that. That means that people were reluctant to talk shit about this computer to its face, but they're willing to talk about it behind its back. That's a very strange thing, so much so that the media equation as a concept became known as computers as social actors, or CASI, because what they realized what was going on here is that we human beings are so hardwired for social connection that we'll often forego reality to play along with technologies that are willing to present themselves as even vaguely social. A computer that pops up a few messages of encouragement, we will suddenly treat nicer. A robot that acts kind of human-like will play into it and will allow it the same kinds of affordances that we would speaking to another person. Now, this is a really cool phenomenon, and like all good technologies, this can be used for good or for evil. If anybody remembers on the left here, these wonderful crazes in the 90s, the Tamagotchi. Tamagotchi were fun little things where you had a little digital animal inside that you were urged to keep alive by essentially walking. It was nothing more than a pedometer with a cute little icon on the screen. But this was actually a huge phase. They sold like hotcakes, and hopefully they also did some good in the world by getting people exercising more. Now, on the flip side, though, you look at things like modern VR or digital casinos, where you have avatars and other digital profiles that are interacting with you and encouraging you to gamble more. This is what I would believe to be a very evil and bad example of using this type of technology. But why do we still want to push forward with this kind of research? Well, because it could still be critical for a lot of social tasks. In my lab, for example, we do research on a lot of helping people age in place or in different care environments or care homes, and things like even just finishing a meal. Individuals with mild Alzheimer's often struggle to finish a meal because they need reminders. They forget that they're eating sometimes. And so we did some experiments in our lab years ago where we had a robot that sat there and talked with someone and encouraged them to eat the whole time. And it was quite successful. Similarly, something as simple as picking out clothing for the day that's weather appropriate could be rather challenging for some people as they get on in years. But if a robot can guide you through, it can help you pick out your clothing. But in both of these instances, the robots need to at least have a basic understanding of persuasion because they're trying to get you to do something. And we hopefully agree that that something is a good thing, but we still have to give the robot enough agency to persuade you to do so. Now, I told you I didn't want to talk too much about my research today, that I wanted to play more, but I should actually tell you a little bit of what I did. So I dealt with persuasive robotics. One of my first ever experiments was the sort of now infamous jelly bean experiment, where I ran that basic carnival game where people had to guess the number of jelly beans in the jar, with a little bit of a twist. I had two robot buddies on either side trying to persuade people to change their answer using different persuasive strategies. So, things like a logical strategy. My computer vision system can detect 483 jelly beans in the jar. An exclusivity strategy, psst, don't tell anyone I told you this, but there's actually 904 jelly beans in the jar. However, far and away, the most effective strategy of all was an emotional strategy. A robot saying something like, "It would make me happy if you use my guess of 742 jelly beans in the jar." That was far and away the most effective way that a robot could persuade you to change your answer, which is so weird. I'm sitting here as a roboticist saying, they're robots, they don't have emotions. I even had participants say that very thing to a robot's face and then still take its suggestion. And this confused my poor little engineering brain for a while until I thought back to the media equation. Because in the same way that people didn't want to hurt that computer's feelings, they wanted to take this opportunity to make my robots happy. Okay, so this is a bit weird. So let's dig deeper. What else can affect persuasion? Well, communication, how you say things, is a very important thing. And so I started to look into different forms of communication, how direct or indirect, how sort of blunt you say something versus sort of circuitous and around the point. And I had different robots saying a lot of different things to try and persuade people in a slightly different task this time. They were asking to either borrow someone's phone or they were asking for some of that person's time to teach them how to be more human-like. And what we found here was that indirect speech was actually far more effective than direct speech. And so this is maybe not too surprising when you think about it. If a robot's too direct, it might come off as blunt or maybe even rude. But the implications of this are potentially a bit scary because, once again, if we prefer to think of robots as having this vague and unclear speech, do we always know 100% what we're trying to do with them? Do we always fully grasp the intent of what's going on? Could we be actually preferring a way of speech that shades us from the true intention of the interaction? Now, never wanted to dig deep, stop there. I wanted to dig even deeper. And on this last one, I really wanted to swing for the fences and find something weird. So I did a study on authoritative robots. Yes, authoritative robots, putting them in charge. And man, this was my favorite one by far. I had so many interesting anecdotes that came out of this, so much weird findings. People got really uncomfortable when you put a robot in charge. In this case, one of the conditions where the robot was the authority figure versus a peer, in the authority figure, I had my participants actually walk into the room with no human there. The robot welcomed them in, asked them to close the door, had them sit down, asked them to sign a consent form, and then walked them through a 20-minute long interaction where they were trying to guess certain things about counting games and memory games. And meanwhile, the robot would periodically make a suggestion to try and persuade them. In another one, I was the experimenter running the whole thing, and we had the robot there as a peer, sort of framed as a friend, there to help them. And we saw, well, okay, how do these things work? And what we found was, okay, kind of unsurprising, I suppose, that people don't like robots in authority positions. Now, people were also incentivized, either with rewards or punishments in some of these cases, to get the answers right, and they especially don't like robots in authority positions when they threaten punishment. And then, of course, I dug a bit deeper and even looked at some of the demographics of this, and the especially don't like it if you're a man. This was a kind of an interesting one, but when I actually dug into the literature, I usually didn't find many gender findings within all my research, but when it came to this one, we had a very, very visceral response from men when the authoritative robot was trying to punish them. And ultimately, as I dug into the psychology research, the only real explanation I could find, even though it's a hypothesis, was that there's something about the male ego that always has a bit of defiance towards authority. And so, while it's maybe a little bit surprising or hard to believe that a robot could play on this sense of, defiance, men were feeling that their own sense of autonomy was threatened by a cute little robot named Pepper, not even that weird military thing that the Indian government decided was a good idea to propose. So I know some of you are probably looking at me like I'm a true mad scientist now, but I want to remind you something very important, which is summarized so elegantly by Elliot Kranzberg's first law, which is that technology is neither good nor is it bad. However, nor is it neutral. I'm not trying to use this to sort of say, oh, look at the weird research I did. No one could ever get hurt by it. But I am trying to remind you that what we do with this research is now a decision, but we can't simply decide to do nothing. We can't put technology out in the world and just let it be, because bad things will inevitably happen. Because the problem is, not everyone is playing fair. And this is maybe a bit of a jump, but I think it's important to bring up, because when I talk about my persuasive robots, I think immediate analogs come through when we talk about other persuasive technologies like Facebook. This was played out in front of us in the last 5 years, where you had things like the Cambridge Analytica scandal, or even the Myanmar genocide. YouTube is a source of extremation. Please, after this, no one click on any Joe Rogan videos. That's the beginning of the click hole that gets very deep. But these are examples where technology is able to influence us, and it doesn't necessarily have to sit there and change your mind drastically on a subject. The whole point of technology is that it can be very patient and very slow and happen on a large scale, such that it doesn't need to change your mind completely, because it can brute force the human mind en masse. We look at Facebook's algorithms, and they don't care if they influenced you. They care if they made a nudge in a small percentage of a million or a billion people. And so when we think about persuasive technologies like this, it suddenly comes down to what we do with them and how we can automate this type of work. Because if Facebook had to convince every single person to vote Republican back when the Cambridge Analytica scandal happened with people, that'd be impossible. But technology allows us to do things at scale. So can we automate persuasion? Of course we can. Facebook has proved that very well. And of course, because I'm doing social robotic stuff, I had to check, could we do it with a robot? And so anyone who really wants to dig in some fun reinforcement learning, you can go and look into how I created a different architecture to think about how to persuade people. It would do things like take a look at you and try to understand implicitly, well, do you have a, high need for cognition? Like, should I be approaching you with more rational arguments? Or do you have a low need for cognition? Should I be approaching you with more emotional arguments and try and play on your peripheral form of processing persuasion? Getting into a little bit of elaboration likelihood for all my psych students out there, a bit of Petty and Cassiopo right there. But might also do things like look at your emotional affect, which is also very contentious and problematic. But if I'm happier one day, how should you persuade me? If I'm sad one day, how should you persuade me? If I'm angry one day, how should you persuade me? Because this is the challenge. All these studies that I ran, they found some interesting insights, but ultimately, we human beings are such complex individuals that we need to not just think about how to persuade humans, we need to think about how to persuade you and the context and moment of what you have going on in your life. Now, when I ran this algorithm, I will say it persuaded the hell out of people. Granted, these people were digital simulations that were exceptionally reductive and simplistic versions of a human, but, COVID happened and I really couldn't do much physical study at that point. So even beyond this, though, I will say, had we had the opportunity to work with people, there's a lot of methodological issues that come up when you start studying people in very closed and contrived environments. But I was able to show that, yeah, you can start to learn people's preferences, and this is sort of the value proposition of artificial intelligence: is if you give it enough data and there's common trends in that data, then eventually it will predict what's next from that data. And sure enough, we were able to do this in simulation. And God forbid, this is the kind of thing now that we could take and, much like Facebook has done, Google has done, turn this out on a human with a robot. Now, is that scary yet? Maybe a little. I hope you're scared. I want you a little bit scared because the point of this is that you need to be making the decisions about how you interact with this technology. Okay, so how is this technology changing? If we're thinking about today, that Shane's already made weird stuff like this, but granted, it's janky as all hell, and it's probably never really going to see the light of day because I'm keeping that code in my computer because I'm a little scared of it myself, and I've actually lost some sleep, but I digress. We should look to the future, because as scary as you might think the stuff that Shane just did, let's not be naive. This kind of work has been going on behind corporate closed doors for eons and ages in ways that we can't even imagine. That's probably far more advanced than anything I've done. So let's look more to the future. What happens as technology like this gets better and better? Well, some of you might have heard this story before, but it's one that I really love. It's a thought exercise that we think about when we look at a company like Amazon. So Amazon today is a book retailer. They started as a book retailer. They now sell everything. And many of you, whenever you've bought things on Amazon, have probably seen after you click purchase, something will pop up and that says recommended for you. And, maybe once or twice you've actually seen something in there that was valuable and you've clicked on it and said, all right, I'll buy that too. Now, I've been doing my best to try and stop using Amazon full stop, but I am at least still fascinated by Amazon as a case study. Because when you think about Amazon and that recommended for you thing, that isn't just a neat little feature. That's something that in the future has the ability to fundamentally change the way that Amazon's business model works. And this is where I'm starting to riff on some great material from a book, Prediction Machines, by Ajay Agrawal and his crew. And one of the thought exercises they put forward is when you think about that recommended for you section, could there be a point where it becomes accurate enough that we could actually change the way that Amazon works? So right now, you see something that you want to buy, you click on it, you click buy now, and it gets shipped to you. Now, already, their predictive algorithms have gotten it so that in the background, what you don't see is they've actually started to warehouse things in different locations based on some of those predictive analytics to both reduce shipping time and optimize some of their supply chain. But what if that keeps getting better and better? Could there ever be a point at which Amazon knows you well enough that if you've opted into something, it could just send you something before you even agree to it, before you buy it? That would fundamentally change Amazon's business model from being a retailer that sells you stuff in when you buy it into being a predictive retailer that sends you stuff before you need that it, but you will be willing to keep it. And now I know this sounds crazy, and everyone's thinking, well, no, I would never accept that. But really, really think about it. Isn't there a point at which that algorithm could become good enough? Maybe it's 50% of the time, 70% of the time, 80% of the time, 90% of the time, whatever that number is, that people keep the item that's shipped to them, that it does make good business sense for Amazon to keep doing it. This is what happens when technologies like artificial intelligence and robotics start to hit these big leaps, is they fundamentally change the way that we work. This is what we know as disruptive innovation. So, if that's what something like artificial intelligence can do to Amazon's business model, what happens as robots improve? This is a picture that I love. It's of the gemoids made by Hiroshi Ishiguro. He's the one in the center. He's famous for at robotics conferences. I actually saw him once years ago. He'll sit right beside his gemoid, dress identical to it, and just sit there as motionless as possible and watch people walk by and sort of turn their head awkwardly and try to figure out which one's which, because it is actually from a distance quite difficult to tell. So these are already some really impressive robots, but as they get better and better, as they get more and more human-like, what do they become? If Amazon goes from being a shipper into a predictive retailer, what does a robot become? Well, this is where I wish I had better news, but if we look at what's going on with a lot of the large corporations right now, I don't have a very positive view on the future of robotics unless we start thinking about how to regulate them differently or we start getting some companies that are operating more ethically. Because right now, if you think about what a robot will be in the future, I don't think they'll necessarily be a companion, although some of them will hopefully be designed by smaller companies to work in care environments. I don't know that they'll be a coworker, although some of them will be when we hopefully start getting robots that are well designed for things like manufacturing. But as it stands, with the way I'm looking at big tech, I see the future of robotics as them becoming influencers. And why this bothers me is because suddenly they'll be able to operate at a scope and scale to influence humanity in a way that we've never seen before. If you thought Facebook could do a lot with simply nudging you with different words and advertisements, imagine what a robot in your home could do if it was able to speak to you much like a human could, and literally have the tenacity to speak to you every day about the same thing with slightly different language that maybe eventually will convince you. Now, you're probably wondering what the hell this picture is. This is Will Smith on the most awkward date of his life with Handsome Robotics' Sophia. Now, Sophia has gained quite a bit of notoriety recently. Sophia has spoken at the UN. It, not she, it has done numerous talk shows like Ellen, and it was made an honorary citizen of Saudi Arabia in 2017. Now, you may be looking at all this stuff and saying, well, this all just sounds like a big marketing stunt. And you would be exactly right. This is the point. Sophia is not even that impressive from a technical perspective when you look at other robots being developed. Yes, it has a lifelike face, but the intelligence isn't mind-blowing. It's nothing necessarily leading the industry. There are some good innovations there, but the most innovative thing that Handsome Robotics has done is in marketing. They have created a robot that is a social influencer. And when we think about humans as social influencers, they're already terrible enough. So can you imagine what would happen when we give that kind of authority and power to a robot? Well, the issue becomes now we're dealing with a machine. And machines are often goal-oriented without context. I love this picture because it shows three parts being designed. One purely by a human, the middle one by a human using generative design to sort of optimize some of the stresses within the part, and then the last one being designed by some artificial intelligence to essentially be given the endpoints and say, you need to hold these kinds of stresses. That last part looks alien in nature. And this is the thing that a lot of people don't understand about artificial intelligence. It will get the job done, but the way in which it will do it will be so foreign to us that we may not even understand it. And the problem is sometimes that method will be without any morality or judgment unless we've programmed it as such. As much as I didn't want to demonize robots and bring Terminator into this, Skynet is actually a great example. Skynet was not evil when you think about it. The goal of Skynet was to actually help and keep humanity safe. The problem was, Skynet identified that humanity was a danger to itself, and so through a convoluted logic was able to now take over and enslave humanity because that was the safest thing to happen to them. So this is the issue, is that unless we explicitly program a robot or a piece of artificial intelligence to do something, the rationale and logic that it can use to accomplish its goals can be very counter to what we actually intended. This is no more better epitomized than my personal favorite way in which the world could end, which is known as the gray goo scenario. So now imagine if there was something known as self-replicating nanobots, so super tiny machines that could build themselves. And you told one of them, hey, can you go make a lot of yourself? And I, the designer of these machines, never specified in the code what a lot meant. So suddenly these things start just replicating themselves. And let's just say, to a machine, a lot means nearly on the order of magnitude of consuming the entire matter of the Earth. And so these little nanobots suddenly become an uncontrollable virus that deconstruct all matter on the universe and take them all to make more and more nanobots, and the entire Earth just turns into a big nanobot factory. This is the Grey Goo scenario, and while it's obviously a bit of a joke, it is a perfect way to highlight that robots don't have intention of their own. They only have the intention that we program them. And so once again, I go back to Krendsberg's law. Technology itself is not good, nor is it bad, but nor is it neutral. And that last part is the most important part, because that last part is the reminder to those of us who design technology that we are ultimately the ones accountable for the ultimate objectives of these things. I often call myself a robot sympathizer, and that kind of weirds people out. But I mean it when I say it. I love robots, and I actually think that I wish people would quit blaming them. I don't think that anyone should scapegoat a robot. When you say things like robots are taking our jobs, that's actually a big inaccuracy. Executives are taking your jobs. They just happen to be using robots as the tools to do it with. This is the key with any technology. It's a tool. Ultimately, the intent of how we use those tools lies with us. Another question that I get asked a lot, in addition to should I do a PhD, is Shane, you're studying robotics. When are you going to take over the world? Yes, you're all very clever. Now, I've heard this so many times that I've actually developed a formulaic answer to this question, which is as soon as I tell them to. And other than really enjoying getting to watch people awkwardly shift at the strange answer I've just given them, there's actually a little bit of a lesson in there. It's a reminder that robots are never going to take over the world. They will never do it of their own volition. They will only do it if somebody like me tells them to, or through my own stupidity and omission, make some sort of ignorant code that allows them to take over the world through some flawed logic that I never thought of. This is what Thomas Sheridan ultimately calls the objective function. And he says that no matter what we automate, at the end of the day, the objective function will always belong to human beings. We are always going to have the first say about what something like a piece of technology is going to do. That's a really important thing to remember, so that no matter what technology you're designing or using, you are the one that has to have the responsibility for what happens with it. So, what have we talked about today? I hope I've scared you a little, because that's the point. Because I want you to be knowledgeable about this stuff. I want you to make informed decisions about how you will integrate with these kinds of technologies. Because the robots are not coming. In fact, other than this creepy, weird Japanese teddy bear lifting robot in a hospital, in many ways the robots are actually already here. Whether it's social interaction robots in the UK to combat loneliness, funeral service robots in Japan to both reduce disease exposure, but also find a more cheap way because there's so many deaths happening in Japan with the aging population there. Meditation guiding robots in Europe, or translators and greeters in North America. There are already millions upon millions of social robots, and there's predictions that sometime in the next decade, the number of physically embodied humanoid robots is set to surpass humans, which is crazy. But if this happens, they will become not only an important tool in our lives, but a very critical part of our social fabric. Now, I put a lot of scary stuff out there, and I always hate ending on a downer, so let's take this home in a slightly more positive note, shall we? The big question is, you're probably wondering, is, well, how can tech like this be ethical? Should we not just ban it all? And I say to this, of course not, because the technology should still have a lot of value. We still can see so many good applications that help people, but we need to make sure that we are demanding the right regulations and the right checks and balances be put in place for this kind of technology. And it's not difficult regulation. Ultimately, if you asked me, how do we make technology like social robotics, persuasive technology, things like that more ethical, it comes down to one simple word, which was really well captured by Werderman Theodoros' paper a few years ago, which is transparency. All we need to demand of this technology is that it's transparent with us about things like who owns or operates that technology, what are the objectives of that technology, what types of approaches, both data that it has at its disposal, but also even capabilities that it have. What can it tell about reading my face? Does it get to look at my Facebook data, or does it get to understand things from reading about me on the internet? And then I go one step further to even say, not only should we know these things up front about the robot, but if they're going to be masquerading as human beings themselves, shouldn't we insist on those robots having the same kind of social feedback that we do? You know, if I looked in your face and started trying to manipulate you, that would make me feel kind of bad about myself, and you'd probably see me maybe cringe or at least look a little bit awkward. That would let you know something's wrong. A robot's able to do this without any flinch of remorse or fear. And so, how do we actually start programming things like empathy and remorse, fear, things into robots that give us the feedback to let us know what's going on with that social interaction? These are the kinds of things that we need to be thinking about for the next decade of social technologies, because unfortunately, the last decade was not a positive one. But I'm still an optimist. I still believe in robots. However, I only believe in robots if we're the ones that take control and start demanding better of them from the people that design and make them. Thank you, everyone, so much for your time. I wanted to save about 15 minutes, and wow, like clockwork, we've got about 15 minutes left for question. So I'm going to open things up and start watching the chat a little closer here. And if anybody has any questions, by all means, we've got about 10, 15 minutes to get into some fun. So fire away. I see one from Jamie already here. What kinds of cultural or social economic backgrounds characterize your participants? Oh, we're going to get into that stuff. Come on, Jamie. Um, so definitely most of my research was, of course, as is very stereotypical and problematic within any kind of psychology research. It's limited to largely university students, although some of the studies I actually did with older populations as well, because I wanted to look for age differences. But I weirdly didn't find many age differences. And I was working with people up to 70, 75 years old. It's kind of interesting that we often assume there's going to be big age differences when we talk about technology, but I was only able to find gender differences, not age differences, in any of the work that I did. That said, of course, it was all done within Toronto and largely around the University of Toronto, so a lot of students on campus and things like that. But I also tried to go sometimes down to office buildings or hotels and get older populations too to get a little bit more breadth, but it still comes with those caveats. So looking down through here, I want that slide. I want my better robots. Siegel, can you review the numbers and measures used in those fancy graphs of yours and what do those things actually mean? Okay, well, I'm happy to, but as much as everyone on this call probably wants to talk about statistical significance with me, any of the claims that I made, so things like the emotional robot was more effective than the logical robot, that was statistically significant. The indirect approach was more effective than the direct approach. That was statistically significant. The peer robot was more effective than the authority robot. These were all when the robot was trying to influence people to do something. And for those of you who don't know, statistically significant is just a term that grad students live and die on because it means that within a reasonable percentage of doubt, you assume that these results would be replicable. Looking through here, Christopher Thompson, if you had to do one more study after this based on what you've learned, oh, what would be next? Chris, that's a great question, and I'm going to answer it in two, even though this could get me in trouble because academics aren't supposed to reveal what's coming next. Fortunately for you, I'm not an academic, and I don't want to keep doing research. I think the two things that I would do are, one, I would take that architecture that you saw, which had designed and simulated to sort of persuade people, I'd want to run that with actual human beings and not simply to see if it was effective, but actually to see how people feel about it. So put that kind of a system in, say, an elder care facility and have it do something like persuade someone every day to do their exercises. So every morning, let's say a robot does the rounds and it pokes its head in. It says, good morning, Mrs. Smith. Hope your morning's going well. Just a reminder, you're supposed to do, 10 arm raises and whatever. And have that robot try and persuade people to do something every day. My curiosity there would not simply be like, is it effective, but how do people feel? And not just on day 1 and 2, but after a week of this, after a month of it. How do people feel about interacting with a robot? And do they enjoy the experience? Does it get annoying? What do they want to do with it? The second one I want to do would be much more on the psychology side, which would be digging a lot deeper into the sort of why. Why are we seeing things like that media equation effect, where sometimes we look at a robot and we play along with the fact that it kind of is operating like a human being? And why in other situations do we actually look at a robot and we defer to it like it's just a basic tool, like a hammer or, something that we want to just use to accomplish a task? I have some hypotheses that it actually has a lot to do with something called dual process theory. which is a sort of framework or model that, it's a little bit dated and has some contentious issues, but dual process theory really looks and says the human brain often has sort of our, classical reptilian brain, which is very immediate, intuitive, and responsive, and then our more modern rational brain that really stops and thinks about something. And I'm really curious to design an experiment that actually looks at people interacting with robots to see if we can find a breaking point for that dual process. When do we flip from having our, traditional intuitive brain look at a robot and say, "Oh yeah, you're a human like me," to suddenly something breaks that veil down and we look at the robot and say, "No, something's not right here. You're just a hammer. You're just a tool. I don't care." I see one here. What ethical or moral laws would you recommend for individuals who are in a role and directing what robots do? This is a great question. I will admit, as a young engineer in my 20s, this stuff was nowhere near my radar. And I unfortunately have to kind of blame my education because during my undergrad, I think I had one or two electives for the entire degree and only one course on anything even remotely ethical, which fortunately was on climate change at the time, but did nothing to make me start thinking about some of the ethics of things like the implications of using social technologies, definitely nothing down the line of persuasion. I got into a lot of the ethics of this literally of my own volition because after that first study, late one night, I'm doing my analysis on the stats and run through, and it turns out, boom, the most effective strategy is the emotional strategy, and it validated with statistical significance. And I get very excited because that means I have publishable results. But then almost immediately afterwards, I get sacked because I go, "Oh my God, I've just emotionally manipulated people with robots, and that's strange." So I think a lot of people during early engineering education really should be shown this kind of stuff. I didn't know about things like Kranzberg's law, and I think that's such a critical thing to put in front of young engineers to have them start thinking differently about how the types of technologies that we make can actually operate and work out in the world. Sorry, my answers are a bit long-winded, and I'm maybe getting some stuff lost in the chat here. But I see Andrew saying, "Did you gather data about participants who were doing the jelly bean count, and were there particular attributes of the groups that were or were not affected?" Good question. So I didn't talk about all the findings because there was lots of little ones. One of the things that I did collect in the jelly bean experiments was actually occupation or field of study for students. And what was interesting, there were sort of two things that came out of that. One, probably a bit unsurprisingly, individuals from fields like engineering and physical sciences were slightly more persuaded by logical strategies compared to the rest of the population, but still more persuaded on average by the emotional strategy. And then the other one that was kind of weird was that individuals from engineering, business, and the physical sciences were all generally more susceptible to being persuaded by a robot. People from the social sciences and humanities seemed to have more skepticism towards the robot and didn't want to actually take any of the robot's suggestions when it was influencing them. So potentially something interesting there. I see something here from the Digressive podcast. Oh, Christoph, how you doing? Is the academic world ready for these ethical questions, or is the private sector faster? What is needed so that researchers can have an impact? Oh, man. I wish I had a better answer to this because I honestly don't know how to have a better impact. I think you're right to call out that right now the industrial world is moving too quickly for a lot of governments to catch up. So I don't know that we can completely rely on regulation. Although thankfully we are finally starting to see some regulation both at a local and global level on things like artificial intelligence. But I actually do believe that going forward, we're going to have to rely more on the corporations to somewhat police themselves, which sadly never works well. And so the only way that works is if we, the consumers, start doing a bit more voting with our money. You're starting to see bits of this. People are leaving Facebook in droves because of some of the ethical issues that they're going through right now. And I hope that as a society, we will become more and more demanding of things like this. If robots start getting introduced in the world, I want all of you, whenever you see a robot that's designed for some task, to walk up to either the robot or a person standing near it and say, "Who is the owner of this robot? What is its objective? And what kinds of capabilities does it have to accomplish that objective?" These should be things that you demand when you're interacting with these kinds of technologies. Because if you don't, you have no idea what could be going on there. Ashley, is there an overlap between persuasive techniques with robots with robots that, for lack of terms, look like robots. Oh, or those that look like more sort of standard devices. Yes, short answer. I didn't do a ton of work on robot embodiment or morphology, so how they change. But there is actually some really interesting findings that come out of this. I'll cite one study in particular by Christoph Bartnek and his group, some stuff that was done in the Netherlands about 10 years ago. They ran a study where individuals came in and were asked to do a series of increasingly invasive medical procedures in a medical checkup. So they were initially asked to do things like, open your tongue and say ah, so they could look down your throat, maybe to do some basic range of motion stuff. And then it started to get a little bit more awkward. Say something like, can you take off your shirt or your clothing? And eventually the final step was that it would ask you to rectally administer a thermometer. So the whole point was to see how far would people go with different interactions. And in the setup, they had a human nurse that would guide you through this. They had a robot with a face that would guide you through this. And then they had a robot that was just a box that would speak to you. And what was really interesting was in this case, there was a positive aspect of the box alone, which was that people reported lower feelings of embarrassment. And so what's interesting is there are actually circumstances in which we don't want our robots to be human-like, because being a human-like robot will remind people of also human-like characteristics and difficulties like social embarrassment. So even things like psychology. If anyone remembers 1967, Eliza was the very first chatbot ever made, and Eliza was designed as a very rudimentary psychiatry chatbot where it would say something like, tell me how you feel. And I would say, well, I'm feeling, happy. Well, why are you feeling happy? Well, I feel happy because I'm, finished my PhD. Tell me more about your PhD. It was a very simple pick up on keyword and ask you a question from that. But the world around said, this is incredible. This is the latest and greatest in, therapy. We don't need humans anymore. And while they definitely got wrong the aspect of a robot could easily do a psychoanalyst or a therapist's job, the one part that was maybe right in all that was that by using a machine in that instance, you potentially have the ability to make people more comfortable. They might disclose more, they might feel better about the situation or circumstance. So robots actually could play a role in terms of collecting sensitive data from people that people otherwise might feel embarrassed about to speak about to a human. Siegel, question from a colleague. Did he come across any similar phenomena to the uncanny valley with regards to a robot's social behavior? Yeah, I'll talk about Uncanny Valley, even though I kind of intentionally avoided in this, because there's a bit of contention around the Uncanny Valley. It's actually been a phenomenon that is a little bit difficult to replicate. For those of you who don't know, the valley is referring to the shape of a curve where people's familiarity levels rise with a robot as it starts to look and act more and more human-like, but right before it gets fully human-like, it takes a dip. And that dip is ultimately because it's hit this strange point where it's a little bit too human-like, but it's still flawed. Fun factoid, actually, the uncanny valley effect is also known as the zombie effect because it actually plays on the very same human intuition and emotion that we have when looking at sick people. So if I'm out in the wild, I have an instinctive aversion to someone who looks sick. So if you're coughing all over the place and looking all disheveled, I'm going to want to physically stay away from you instinctively because I'm scared of getting what you have. The uncanny valley effect is hypothesized to work on that same idea, which is that a robot, it becomes close enough to being human, but something's a little off on it. It doesn't look right or it doesn't move right. And so we think the robot itself might be sick. I didn't see any of that within my own research, likely because the robots themselves were not, they were human-like, but they don't have skin. They were plastic. There were things like that. The only time that I might have seen a glimpse of it was in the Authority study, where people commented on being quite afraid or feeling dominated or scared by the robot because it was acting authoritatively. It would say things like, I will punish you if you get the answer wrong. Financially punished, don't worry. No humans were abused in the making of this research. But that gave us a really interesting insight into the fact that, okay, people do still believe that this robot has some sort of agency or authority because they're really, really denying it in this sense. They don't want to be punished. So long-winded answer to the question, but in short, I didn't see a lot of the uncanny valley effect. There's a little bit of contention around it, but there's still potentially some cool things to learn in there too. So Harris, what are some of the technical and social challenges that social robotics companies will have to address in the next 5 or 10 years? And follow up, and what can practitioners learn from a commercial perspective for early social robotics startups? Oh man. So there's two things I'll talk about here. First, a fun one, and then the sad business one. The fun one is if anyone looks at commercial and social robots right now, you'll notice a very interesting trend, which is all of them look kind of like maybe an 8 or 9 year old kid. They're all cute. They have big eyes. They're usually kind of short. And this is not just some weird visual trend in robotics design. This is done very intentional. And it's done so to use a thing called pedomorphic design or childlike design. Um, Robots are currently being designed to look like little kids because that's what we want you to think about when you interact with them. Because that does two things. One, it lowers your expectation of the intelligence that you expect out of this thing. You're not going to treat it like an adult human. You're going to treat it like an 8 year old. And so if it screws up a little bit, you'll maybe be more forgiving. And then two, you're also going to approach it thinking that it's slightly more innocent. And so you'll be a little bit happier. This is a very strange phenomenon that was noticed in social robotics a few years back that now a lot of companies are capitalizing on because they've realized you can actually set a lot of visual cues for people in how a robot interaction will go. So if I create a big hulking, military looking bot, then that might scare me a little, but it also might instill confidence in me if I want to hire a robot to be a security guard. Whereas if I see something that looks very smooth, compassionate, like the movie Big Hero 6, soft and cuddly, yeah, that connotes feelings of care and compassion and emotion to me. So there's that aspect, Harris, I think, where we need to be thinking about the visual design because I think the visual and nonverbal behaviors of something have a lot of social cues to them. But then on the other side, when we think about this from a commercial perspective, I'm actually a bit of a naysayer right now when it comes to robots, and have been for quite a long time. Social robots, I should say. Sorry. Manufacturing and other types of robots really found their stride. 70s, 80s, 90s, we started automating car factories and other places, and robots had a tremendous effect there. The issue now is that robots from a technical perspective are really, really hard. And I don't think we've solved enough of the challenges to make them truly functional and useful in a lot of social contexts. Because the problem with social contexts is you're dealing with social beings, us, humans. And our expectations of social interactions are so high that it's difficult for a robot to live up to those. So I guess the recommendation I would have for people playing with social robotics right now is find your niche. Roomba was an exceptionally effective robot, not entirely social, still quite functional, but it was effective not just because it was a good engineering design, but because they found a use case that was both technically feasible, but also useful to people. That's what I think social robotics companies need to be looking for right now is that killer app, that thing that people actually want. But as it stands, I've been playing in this space for almost 20 years, and I still don't think I've really found something that people care about that much to play in. So I realize it's after the hour, so anybody who needs to run, feel free. That said, I'll probably stick around for 5, 10 more minutes and see if there's any more questions. So if you have to drop off, thank you so much for your time. If you don't, let's look at a question from Kristen Power. Long time no see. In clinical research, there's been decades of injustice to minority groups who are not represented in clinical trials. What is done here to make sure there's diversity in your data? Great question. I'm lucky for my own personal studies, which is that I live in Toronto, and especially U of T campus is probably one of those multicultural places you can imagine. So without even trying, I was able to get a massively diverse population from both a racial, cultural background, gender identity, gender sexuality, things like that, just by being on U of T campus. That said, I already acknowledge that there are limitations to my own research. Probably about half the studies that I did were run almost exclusively with students, so there's going to be an age bias there. Even if we look at all the good things that I did with my populations, the fact remains all of my studies were still run in Toronto. So that means we're going to have a Canada bias or a North American bias. The types of studies that I did, I'd be really curious to see what would happen if you ran them in somewhere like Japan or in Germany or in other contexts where the perceptions of robots are maybe a little bit different. I sadly think that there are more and more people that are trying to encroach on this, but it's a hard thing to do because, as you know, Kristen, from doing grad studies yourself, a lot of times you just need to get stuff done. So I'm lucky that I had some things automatically going for me, but I'll admit that I didn't do as much as I probably could have to make sure there was even more diversity in my data. Emma, do we need to think about how humans treat robots? Yes. I think we chatted about this once with the places and thank yous of Alexa. Yes, and even though I hate the show, here is where I will cite it. Black Mirror, for those of you who don't know, is of course a reference to this. And why it's called Black Mirror is because the whole point is that these technologies are a reflection of ourselves. And so when we think about interacting with a robot, how we choose to interact with it ultimately will inform how we become ourselves. I gave those examples before of texting. How technology was used ended up changing how we communicate. You know, people say things like LOL and BRB, which drives me crazy, but we do it because technology influenced us to say that because we use technology in a certain way. In the same way, the one that Emma's talking about that we chatted about, I think, years ago was in the early days of Alexa. I had a friend who got the system, and his daughter Harriet, I think, was using the system. And I said, you know, how's it going? And he said, it's good, but there's some problems. Harriet's at that age where we're trying to get her to say her pleases and thank yous. But Alexa doesn't make you do that. So without thinking about it, we've now started to create a generation of children that are maybe not going to be as polite because Alexa taught them they don't need to say please and thank you. Or maybe even more subtle than that, we have to think about the fact that these children are now growing up in a household with mommy, daddy, maybe a brother or sister, but also Alexa. And while those of us who didn't grow up in the era of artificial intelligence may think about Alexa as more just a tool in the corner that I can ask to turn up the volume or tell me the weather, to a 3 year old or a 5 year old, Alexa's another member of the household. So by using technology like this, we are fundamentally changing the social fabric of our families and eventually our workplaces and our entire society. So, yeah, we need to even thinking about the long term implications of what it means to have thousands, millions, or billions of robots floating around our cities. All right, I'll tell you what, I'll give one more and then I'll let everybody go because I'm getting hungry for lunch. Do I see anything else? No, I lied. I'll tell you what, everyone. This was a ton of fun. If you do have any questions, most of you probably have my email address. Don't hesitate to follow up. Or on YouTube, you can leave a comment here, and I'll try to keep an eye out for them. Happy to answer any questions. I hope this is interesting for you. I hope it was fun for you, and most importantly, I hope this made you think a little bit differently about how you're going to interact with social technologies like robots going forward. Thanks again for the time, and take care, everybody.